Hi guys, sorry I can't be with you today, but here are the notes for 5.5. 5.5, parallel and perpendicular lines. Make sure that you spell parallel and perpendicular correct. Today is the 25th of October and this is note page number 19. Alright, we're going to start off with, and you're going to actually learn a little bit of geometry today. So what I want to show you first of all is, let's draw a line. Alright, so I've drawn a line. I've labeled this point right here C. I've labeled this point right here D. And to name a line, remember a line continues off in both directions forever. To name a line in general in mathematics is you need 2 points on a line. So we'll call this point, we have points C and D. And then to say that this is a line, we draw a line with 2 arrows over it because a line goes on both directions forever. All right. Now looking at this line, can we determine its slope? So I say yes we can. So I'm going to use this point. Well, let's actually use C to D. So if I were to count up 1, 2, 3, 4, 5, 6, 7, 8. So that's a rise of 8. So CD has a slope of a rise of 8, which is a positive direction. And then to the right, 1, 2, 3, 4, 4 to the right. So 8 over 4, that's really a slope of 2 or 2 over 1. All right? Let's say I drew a whole nother line. I'm going to grab a ruler real fast. And let's say I'm going to draw this line right here. I already have a few dots drawn. All right? I'm going to call this dot right here, which is at 2, 6. I'm going to call that dot A. And down here at -2, -2, I'm going to call that B. And we would name this line as line AB with 2 arrows over it. And let's check its slope, right? Let's go up and over. So if I go up and over, I could go up 1, 2, 3, 4, 5, 6, 7, 8 as well. Up 8. So a rise of 8, positive direction, and over 1, 2, 3, 4, also over 4. And if we reduce that, we notice that they both have the same slope. What would we call these 2 lines? We call these 2 lines parallel. And I think we've already talked about this a little bit in this class, is that parallel lines have the same slope. And you can visually see that here. So what I want you to write in your notes is this. Is say, if 2 non-vertical lines. What does non-vertical mean? It means not straight up and down, right? Vertical means straight up and down. So 2 not straight up and down lines. So if 2 not straight up and down lines are parallel, and I'm going to underline parallel, then they have the same slope. Okay, and you guys already knew that already. So if we have parallel lines, their slopes are going to be the exact same amount. Now in geometry and higher math, we actually have a symbol for parallel. So remember back to those lines, if I have line AB, I have line AB and I want to say that it's parallel to line CD, we use this really cool symbol, which is these 2 straight lines right next to each other looking like parallel lines. This right here means parallel. So a little setting you up for next year a little bit. So we know that parallel lines have the same slope, and lines that have the same slope are indeed parallel. All right, now I want you to look at this picture, for example. So I've drawn in another graph. Now these lines look, what would we call these? We'd call these looking perpendicular, right? And what do we know about perpendicular lines? We know that they create right angles. Now, remember, anything that's rectangular creates a right angle. So would you agree that this right here is a right angle? So if I wanted to test to see if this actually is a right angle, couldn't I just use my ruler, the edges of my ruler, to see, is this indeed, a right angle? And it is, right? I mean, this is a right angle. So we know that these 2 lines are perpendicular. In the perpendicular symbol, we usually use like this, or this 90-degree angle. We use this little box. All right, so we look at these, we say, hey, look, these lines are perpendicular. Now, do you notice, do they have the same y-intercept? So this y-intercept is all the way up here at 6, 7, 8, 9, 10, 11, has a y-intercept of 11. And this line has a y-intercept of, I don't know, like 2.5 or something. So do you notice that perpendicular lines do not have the same y-intercept? Do they have the same slope? No. If they had the same slope, they would be parallel. So let's look at the slope of these two lines, for example. So I'm looking at this kind of greenish line, right? Here's a point, and here's a point. Is this a positive or negative slope? That looks like a negative slope to me. So I know that my slope of this line is negative something. So let's check it out. So if I count up, I have 1, 2, 3, 4. Up is a positive direction. But then I'm moving to the left 1. So I can also go down though, down 4 and to the right 1. So this guy has a slope of -4/1, right? Let's check out the slope of the red line. Is this a positive or negative slope? This is a positive slope. So the slope of the red line is positive, and let's count from here to here. We'd go up 1, right? That's my rise of up 1, and over 4. What do you notice about the connection between these two slopes? I see that one is negative and one is positive, and then they're reciprocals of each other. Do you notice that it's 4/1 and then flipped to 1/4? That is always the relationship of perpendicular lines. So let's write that down. Let's write that perpendicular lines, so I'm going to underline perpendicular lines, have slopes that are opposite reciprocals. And I'm going to underline opposite reciprocals. So what that means is that if I have a slope that is positive 1/2, right? If one slope is positive 1/2, the other slope would have to be negative 2/1. These would be perpendicular lines. Or if I had negative 3/2 slope, the other slope that would be of a perpendicular line would have a slope of positive 2/3. Okay? All right. So here are a few examples of what you're going to be asked to do shortly. So example number 1, all right, says write an equation of a line that passes through, this sounds familiar, doesn't it? We've been working with this whole time, passes through the point -211 and is parallel, so that's the key word there, parallel to the line y equals -x plus 5. Now, I know I'm writing fast, I'm doing this fast. You can get this on Edmodo to finish your notes if I'm writing too fast. So let's start with our basic equation, y equals mx plus b. Do I know my y-intercept of my line? Now, it is not the same as this line. This is a whole separate line. I'm going to be writing an equation of a line that is different than this, that is parallel to this one. And did parallel lines have the same slope? Have the same y-intercept? Check this out. Did the parallel lines have the same y-intercept? They did not, right? This one had a y-intercept of 6, this one had a y-intercept of 2. So our y-intercept, I don't know. I do know my slope though. My slope, if it's a parallel line, parallel lines have the same slope. So this guy's slope is -1, so that means that my slope is -1. What other information have I been given? I've been given a point, which is an x and a y value. Therefore, my x is -2, my y is 11, and I don't know my b. I have to solve for b. So I end up with 11 equals +2 plus b, so b equals, subtract 2 from both sides, equals 9. So when I go to write my equation of the line that goes through this point and is parallel to this one, I have y equals, my slope was the same as this guy's slope, so -1 or -x, and then my y-intercept I have just found is +9. These two lines are indeed parallel. They have the same slope and different y-intercepts. All right, the trickier one, example number 2, says write an equation of a line that passes through 4, 3 and is perpendicular. Oh, and I forgot to show you the symbol for perpendicular. Let me show you that in just a moment. Perpendicular to the line y equals 4x minus 7. I'm going to scoot right back up to the beginning to my perpendicular. I forgot to show you the symbol for perpendicular lines. So let's say I have the lines, I don't know, AB again, and I want to say that it's perpendicular to this line CD. The symbol for perpendicular, I don't know if anyone knows, is an upside down T. That means perpendicular. Okay, that symbol right there means perpendicular. Okay, so let's start out with what we know. Y equals mx plus b. Do I know my y-intercept? Not necessarily, no. Do I know my slope? I do. My slope, so I'm writing perpendicular. I'm going to steal this guy's slope. Are perpendicular lines, do they have the same slopes? No, their slopes are opposite reciprocals. So what is the opposite? This is really 4 over 1. What is the opposite of that? Would be negative, because this one's positive, 1 over 4. I then know my x and my y, right? This is my x, this is my y. So my x is 4, my y is 3, and I don't know my b. Do some math, I can put this over 1, I can do some cross-canceling. I have that 3 equals negative 1 plus b, plus 1 plus 1, and I get that b equals 4. So when I write my equation of the line that is perpendicular to this one, it's y equals negative 1/4 x, negative 1/4 x plus 4.